Hi everyone, today's lesson is for Geometry CPM students, sections 1.3.1 and 1.3.2, talking about attributes and characteristics of shapes. So let's get started. First we're going to start with a warm-up, and for this warm-up, this has to do with slopes. Find the slope of the line. So this line right here, to find the slope of a line given 2 points, we're going to use the slope formula, which is the change in y over the change in x, delta y over delta x, which says that I'm going to subtract my y's over subtracting my x's. And so that means that I'm going to just choose whichever. If I choose this point, I'm going to go 4 minus negative 2 over negative 1 minus 2. However, I could pick this point down here and say negative 2 minus 4, but I'd need to be consistent. If I go negative 2 minus 4, then I go 2 minus negative 1. So you just have to be consistent in whichever way you find the slope, because they will both be the same. What you also need to recognize is that this is a negative, this is going down, so my slope should be negative. All right, so let's see. I'm going to go 4 minus, so I'm going to say the slope is going to be 4 minus this value down here, which is negative 2, over negative 1 minus 2. So this gives me, in the numerator, it gives me 4 minus negative 2, which is positive, so that's 6 over negative 1 minus 2, which is negative 3, and then 6 divided by negative 3 is negative 2. So for the slope of this line, I get negative 2. For this line right here, to find the slope, what I need to remind myself is this. And both this equation of the horizontal graph, and this looks like this is y equals 2, right? And then this one, which is x equals negative 2. For both of these graphs, they do have a unique answer in that one of them is undefined, right? One of them has no value. So for example, if I'm looking at this equation here, right, and I'm talking about the slope, which is the change in y over the change in x. Realistically, this is my rise over my run, right? And you have to ask yourself, put yourself at a point, you know, could be anywhere. I'm just going to put you here. And if I'm going to go up and over, right? If I'm going to go up, that's my rise. But in this case, I don't have a rise. I'm not going up. So that rise is 0 over my run, and then I can be going 1 or 2 or whatever. 0 divided by any number is 0, which means that the slope for a horizontal line is equal to 0. The slope of 0, because there's no rise, 0. All right, for this problem, however, this one is not 0. This one, think about this, is the rise over the run, right? And so you've got a rise, so you're going to go up. Every time you're going to go up, let's say I'm going to go up 2, but how many am I going to go over? I'm not going over any. Now, when you divide any number by 0, that value is undefined. And so for the slope for a vertical line, the slope is undefined. Whereas a horizontal line, my slope is equal to 0. And this right here just sort of gives me a summary of my slopes. We've got a positive slope because it goes up right. We have a negative slope that goes down right. We have a 0 slope that's horizontal, and we have an undefined slope for a line that's vertical. So our learning targets for today is basically we want to learn how to classify shapes. What makes them different? What are the attributes? We're going to use some Venn diagrams, and we're going to talk about some vocabulary that's going to basically characterize our different shapes. Okay, so how do I classify this shape? The attributes and characteristics of shapes. In 1.2.5, prior to today, you did shapes formed by triangles. We did isosceles triangles, we talked about scalene triangles, we talked about equilateral triangles. We're going to continue working with shapes and then talk about their attributes on their for each one that is individual. So before we do that, we're going to talk about any kind of the difference between a concave and a convex shape. And so what you need to be able to think of, and when I think of concave, I'm thinking caved in, right? Caved in. That's concave. See how this goes like this and it's caved in, right? That's concave. Where it's sort of like you were to take this and like kind of like a balloon, you like blow it up and everything like pops out. That's convex, okay? Meaning everything is out. All your internal angles like that, that's inside angle, this angle is less than 180, right? So that makes it a convex angle. So if you think about that definition, if I'm talking about an internal angle that's greater than 180, what they did was they took this angle, right, and it caved in. Convex angles, again, convex or normal as far as like they popped out, where they have an angle like this, where you have a regular angle that's less than, or you have an angle, not regular, but an angle that's less than 180 all the way around. Whereas in this case, this angle right here, if you think about it, if you were standing right here, that angle is way more than 180, because 180 is a straight line. So that's maybe even 200, 220 even. I think that's a pretty good estimate. There is a link on your assignment, and I want to talk about that, because what this does right here is, if you look at this, this is a regular polygon. It starts off as a regular polygon. And a regular polygon has all sides congruent and all angles congruent. And what happens here is basically, as you move this in, now watch what happens. That angle then pops out, right? Now it's a concave pentagon. So it's telling you, hey, if it's caved in, concave. It's poofed out, it's convex. Okay? All right, that's kind of cool, I thought. All right, so let's move on. So we have so this is classifying some of our shapes, our basic shapes, okay? We have a quadrilateral. What you need to know about a quadrilateral is it's any four-sided shape. That's not distinguishing it between any of the main ones, but it's any four-sided shape. So a kite is a four-sided shape. That means it's a quadrilateral. A trapezoid has four sides. That means it's a quadrilateral. An isosceles trapezoid has four sides. That means it's a quadrilateral. Then you have a parallelogram, which has four sides, which is a quadrilateral. So all of these are quadrilaterals, but the main characters in this case are the kite, the trapezoid, and the parallelogram, okay? Because if you think about the characteristics, and we're going to talk about like each one of these and just say, hey, what do we know about a characteristic of each one of these shapes? And so we're going to talk about that. And right now, if I was in class, I'd put you in a breakout rooms and I'd have you try to come up with characteristics for each of these shapes and see what you could come up with. All right, so talking about a parallelogram is a quadrilateral. That means it has four sides, right? That's all it means. And so if it has four sides, some of the things that you need to know is, number one, both pairs of opposite sides are parallel, which means that they never touch, right? They have the same slope. Meaning, so this line here is parallel with that line, and this line is parallel with that line. Every single quadrilateral that is a parallelogram has both pairs of opposite sides parallel. So parallel, parallel, and we show that they're parallel by this arrow. And then also parallel, and then parallel. Opposite sides are parallel, okay, both pairs. Additionally, the properties of a parallelogram, opposite sides of a parallelogram are congruent. Now, we already know that opposite sides are parallel, but in addition to the opposite sides being parallel, we also know that they're congruent. That side's congruent to this side. This side is congruent to that side. Meaning if that was 10 centimeters, this would be 10 centimeters. And if this was 20 centimeters, this would be 20 centimeters. So far, we know this. We know both pairs of opposite sides are parallel, and we know both pairs, right, opposite sides, that means both pairs of opposite sides are congruent. if it's a parallelogram. So going back to this shape right here, so far we know that's parallel to that's parallel to that, and this is congruent to this, and this side is congruent to that side. That's what that means. Now, because the rectangle, the rhombus, and the square are all parts of a parallelogram, that means that they're subsets of a parallelogram. So what that means is a rhombus has all the attributes that a parallelogram has. So when you think of a rhombus, it's already got both opposite sides congruent, and it already has both pairs of opposite sides parallel. Same with a rectangle. Both pairs of opposite sides are parallel, right? And both pairs of opposite sides are congruent. Now, it doesn't mean that they're congruent all the way around, but it means both pairs of opposite sides are congruent, okay? Now, we've got that one, opposite sides. We've got opposite sides congruent. And we have also attributes for a parallelogram is that the diagonals bisect each other. Now, that's a new word for you. Bisect means cut in half. Bisect means cuts in half. That's what it means. Cuts it in two equal parts. So this line right here is cut into two equal parts. And this line is cut into this line here. So what that means is let's say this length here was 20, that would be 10, and that would be 10. And if this side, this whole line was 8, that would be 4, and that would be 4. And so what that means is the diagonals in a this shape right here, which is a parallelogram, we're not distinguishing it what kind of parallelogram, but in this case, the diagonals are cut in half, and that would be for they bisect each other for a rectangle, a square, and a rhombus, because all of those values are on that right side. Also, a parallelogram is like all powerful, right? A parallelogram also has opposite angles congruent. Remember the sign for congruent? So it has opposite sides congruent, or excuse me, opposite angles congruent. So that means that this angle here is congruent to this angle here, meaning if this was 50 degrees, this also would be 50 degrees. And whatever this angle is here is the same as this angle here. Now think about that, right? We know that parallel lines in a quadrilateral, right? When we were adding up the sum of the angles in a triangle, the sum of the angles of a triangle was 180. The sum of the angles in a four-sided shape is 360. So if those are 100, then I have 200, what do I have left, right? 260 left. So what's 260 divided by 2? So that's going to be 130. So that would be 130 degrees and 130 degrees, which, by the way, this angle here and this angle here, right? Those angles that are consecutive to parallel sides are supplementary, which means they add up to be 180. So, summary of parallelograms. So far, we know that both pairs of opposite sides are parallel. So if we had a shape, right, I'm just going to draw a shape here. Parallel, 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 and parallel. Both pairs of opposite sides are congruent. Congruent. And so this is congruent to this side. That side's congruent to that side. Both pairs of opposite angles are congruent. This angle here is congruent to this angle, and this angle is congruent to this angle. Additionally, the diagonals, right, bisect each other, which means that they cut each other in half. So this side is equal to this side, and that side is equal to that side. Now, there's one additional one that we didn't talk about yet, and that basically says that if you have a parallelogram, if you have one pair of opposite sides, so these are my opposite sides, that are both congruent and parallel, it's a parallelogram. So those are all the characteristics that distinguish a parallelogram. Now, let's talk about special parallelograms, right? Like, for example, a rectangle. So if you think about a rectangle, right, you already know all the attributes of a parallelogram, right? You know that both pairs of opposite sides are congruent. We already know that. We know that both pairs of opposite angles are congruent. We already know that. We know that both pairs of opposite sides are parallel. We already know that. So in addition to those characteristics, and we know that the diagonals, right? The diagonals bisect each other. And so those are 4 things that we already know. In addition to those 4 things, what other characteristics would you say that a rectangle would have? Okay, so I would say we know that a rectangle has 4 right angles. So we have 4 right angles. So that's one extra one in addition to all of these. Additionally, not only does a rectangle have 4 right angles, but the diagonals of a rectangle, yes, I know they bisect each other, but the diagonals are congruent. So the meaning, yes, they bisect each other, but they're the same length. So let's say the whole length was 20. That's 10 and that's 10 and that's 10 and that's 10 because they're the same length. And so if you cut the same length in half, you get the same value. So those are the attributes or characteristics for a rectangle in addition to it being a parallelogram. A rhombus is super cool. Rhombus, again, in addition to having opposite sides congruent, opposite sides parallel, opposite angles congruent, and the diagonals bisecting each other, a rhombus has 4 congruent sides. Okay, number 1, it has 4 congruent sides. Okay, and what that means, and I would say congruent like that. Number 2, the diagonals are not the same length. They're definitely not the same length. You could tell because that's a longer side there. But the diagonals actually are perpendicular. So you would say the diagonals are perpendicular. So that's another thing. You could also say in a rhombus that the angles, right? We already know that these angles are congruent because it's a parallelogram. But in addition to that, the angles, opposite angles, are they are bisected by the diagonals. So not only are the diagonals perpendicular, but the diagonals bisect each opposite angle. Okay, so that's kind of cool as well. And also one other kind of tricky characteristic to a rhombus, and that is not a very good rhombus, and that is if you have 2 consecutive sides like this, right? If it's a parallelogram and 2 consecutive sides are congruent, it's a rhombus. So a rhombus can just have 2 consecutive sides congruent, and then therefore it is a rhombus. Now a square has all the parallelogram attributes as well as all the rectangle and the rhombus. So the square is like taking in all that power from everywhere. So basically a square, in addition to, right, it being opposite sides parallel, opposite sides congruent, opposite angles congruent, and diagonals bisecting each other. In addition to all of these characteristics, a square has what a rhombus has, and that's 4 right angles. A rectangle. It has all the same attributes as a rectangle, which is 4 right angles, right? 490 degrees. It has both diagonals are congruent. Number 3, rhombus characteristics, the diagonals are perpendicular. 4, the diagonals bisect the angles, right? This was diagonals bisect each other, meaning cut in half, right? But so like think about a square, right? if you're thinking about a square, you've got 4 right angles, and then this diagonal that comes across, it cuts this angle into 2 45-degree angles. And then when I have this diagonal, right, also right angle in the middle, also the diagonals bisect each other and they're all the same length. And also the square has the characteristic of a rhombus, and it has 4 congruent sides. So we have 4 congruent sides. Did I get everything? Diagonals bisect the angles. I have 4 congruent sides. Diagonals are the same length. All right, right on. Lots of stuff that you need to remember about these special parallelograms. A rectangle, just to reiterate some of this stuff, is a quadrilateral with 4 right angles. True. A rhombus is a quadrilateral with 4 congruent sides. True. A square is a quadrilateral with 4 right angles and 4 congruent sides. Therefore, every square is a rectangle, a rhombus, and a parallelogram, because the squares are like all powerful. They take in all of the attributes from all of the other parallelograms, and they have that to them. So they have all the other properties for them. So we're going to be using a Venn diagram to classify the shapes. So what you need to know about a Venn diagram is basically it's a tool to classify objects. So we usually talk about more than 2 circles that represent different conditions. You can have an item placed in different parts, and that'll have the appropriate, position based on the conditions met. So basically, if you are in this section here, you satisfy all the conditions that are for A. If you are in this section here, then you satisfy all the conditions for, C, or condition 2. But if you are in the middle, right, in here, which that middle is part of this circle on the left and this circle on the right, and if you are in that middle section, then these items satisfy both conditions, and therefore those are the values that are part of both. There's union. They're in the middle. So what is a Venn diagram? It's a union of 2 or more sets. So for example, you think, and basically what ends up happening is that the diagrams, you're trying to find like that intersection between the 2. So for example, you can ask yourself, well, like, let's say do you play tennis? So who plays tennis? So I could say, well, I play tennis, right? So you could say, okay, I play tennis. But let's say this is Sarah, and let's say this is Kim. Now, Sarah plays tennis. Kim doesn't play tennis. Kim plays softball, okay? And Sarah also does karate. And Karen, though, also does karate. So, like, just based on that one question, I could actually take these 2 values here, right? And I know it doesn't look like it because you can't see that, but that's what I'm here for, and I'm going to draw that in. Not very well, obviously, but I'm going to do this like this. And so I know that both of the girls are in karate, and Karen is also in softball here, and then Sarah does tennis. But do you see when they both do the same thing, okay? If they both do the same thing, that value that intersect, that's that union of things that they do together. That's a Venn diagram. It like classifies stuff. So if you're thinking about like all of our shapes, how many shapes have 4 congruent sides? That would be a rhombus and a square. Well, how many shapes have 4 sides? Well, that'd be all of those quadrilaterals. So you really just have to be able to, come up with a classification that would work to sort of separate each one and distinguish them. So this was a lesson that you are going to do in class. And let me just talk about what this looks like. It's like basically saying, hey, you're going to classify these shapes, and let's see how you do on that. Okay, so if I click on that, I'm going to get, and I think I'm going to, I'm not sure, Desmos maybe? I feel like I should be going to Desmos. Yeah, this thing. Okay, so we are going to go here, and this is where we're at. And so your job is to take a minute and to classify these shapes, and I want to see that. So for example, has at least one pair of parallel sides. Well, this shape, right? This shape has a parallel side. So you're going to like move these shapes here. And then has at least two sides that are equal length. Well, that also is true. So that would have to go in the middle, wouldn't it? Okay, so your job is to classify those shapes and put them into a Venn diagram. All right, right on. That's kind of cool, actually. Okay, so you're going to do that. And then we're going to re-talk about the shapes that we have discussed so far. And we have talked about an equilateral, we've talked about an equilateral triangle. Equilateral triangle has 3 equal sides. So we have 3 congruent sides and 3 congruent angles, because if my sides are congruent, then the angles are all congruent. An equilateral triangle has 3 angles that are congruent, and those angles that are congruent are all have a measure of 60 degrees, by the way. Now, an isosceles triangle has 2 sides congruent. You've got a base, right? You have 2 sides congruent, and that means that you have, so not only do I have 2 sides congruent, I have 2 base angles, right? Congruent. All right, and I have a vertex, right? We have a vertex, 2 base angles. That's it. A scalene triangle has 3 different side lengths. So no congruent sides. Every one of the sides is different. Like that could be 10 centimeters, 5 centimeters, and 3 centimeters. Oh, scalene triangle. So no sides are the same. A scalene right triangle also has 3 not congruent sides, like that, right? But it does have 1 right angle. An isosceles right triangle. An isosceles right triangle has 2 sides congruent and 1 right angle. If I have 2 sides congruent, that means I have 2 base angles congruent. So if you're thinking about it like this, and I know that side's congruent to that side, I know that angle is 45 degrees. And because if you have an isosceles triangle and 2 sides congruent, the angles opposite those sides are also congruent. Now remember, for a square, it has everything. A square has 4 congruent sides. It has 4 congruent angles, and those angles are all 90 degrees. It has diagonals that are congruent. It has diagonals that are perpendicular. It has diagonals that bisect, meaning cut in half, the opposite angles. So like, right, if I drew in a diagonal like that, this angle would be 45 and that angle would be 45 degrees. A rectangle, not as much as a square, but it is a quadrilateral with 4 right angles, check. Both pairs of opposite sides are congruent. Those are the deal for a parallelogram. So you can say, instead of saying all the attributes for a parallelogram, you can say a rectangle is a parallelogram. You can say a square is a parallelogram. Okay, so that will cover all the attributes for a parallelogram. Now, in addition, we also have for a rectangle that the diagonals are congruent, right? Okay, so for a parallelogram, these are our attributes. Let's get them right then. The attributes are, we have both pairs, right? Both pairs of opposite sides are congruent. Opposite angles are congruent. We have both pairs of opposite sides are parallel, and you have the diagonals bisect each other. So you have all of this stuff for a parallelogram. Now remember, a square and a rectangle and a rhombus are all parallelograms. So when you're talking about the attributes for a rectangle, all of this stuff right here also is a rectangle and a square. It's a lot. Okay, more tools. We got a trapezoid. Depending on the trapezoid, one thing that you need to know about a trapezoid, aside it having 4 parts, is that one pair of opposite sides are parallel. That's it. One pair. So one pair of opposite sides are parallel. So what that means is, because if a trapezoid was a parallelogram, then it would have all the attributes of a parallelogram. And a parallelogram has both pairs of opposite sides parallel. And this does not. Therefore, you need to say it's not a parallelogram. Okay? Now, a rhombus is a parallelogram. And in addition to having those attributes, it also has 4 congruent sides. So 4 congruent sides. It has diagonals that are perpendicular. It has diagonals that bisect the opposite side. Okay. Had a moment here. Let's see here. Diagonals that bisect the opposite angles, so that this cuts that diagonal cuts that into 2 equal parts. 2 consecutive sides that are congruent make a rhombus. Now a quadrilateral, all you have to say is that 4 sides. That's it. And well, it is still a quadrilateral. Could be concave or convex. Yeah. And then we have a kite. Now, the kite we haven't really talked about, but what I want you to know about a kite is this. Okay, it is symmetric, right? Y-axis symmetry. What it does is it has diagonals that are perpendicular, number 1. So the diagonals are perpendicular. Additionally, it has the 2 top sides are congruent up here, and this is congruent to that. And let's see, is that it? That's it. So a regular pentagon has 5 congruent sides. It has 5 congruent angles. A regular hexagon, same. 6 congruent sides. 6 congruent angles. An isosceles trapezoid has 2 sides congruent. 2 sides congruent. And 1 pair, right, of parallel sides. And then a circle. Circle is not a parallelogram, but what do you know about a circle? I would say a circle has a degree measure of all the way around 360 degrees. I would say a circle has a diameter, and that diameter cuts that circle into 180 and 180. Yeah. I want to go back, and I want to talk about the sum of the angles in a quadrilateral. So the sum of the interior angles in a quadrilateral is 360 every time. Interior angles, meaning if I add all the inside angles up, I get 360. If it's a quadrilateral, the sum of the angles inside is 360. Now, this is not a quadrilateral, this is a pentagon. And we actually did that exercise where you added 180 each time. So for a pentagon, it's 540. For a hexagon, it's 720. A 4-sided shape, which is an isosceles trapezoid, is 360. And then 360 for a circle. Tonight's homework is 1.3.1 and 1.3.2, but it's actually due today. So we're not going to talk about it being homework It's classwork. We're going to try to finish that during class. So we're going to get started on that. So thanks for watching, and I really hope this helped you.